Here we go. We've got Unit 8, Functions. Today is day 1, Input and Output Tables. So our objectives, we can use equations to create input and output tables, and you can draw a line on a graph using these input and output tables. So we're going to think of equations like a vending machine. You put money into a vending machine, and then you get candy out. With an equation, you put number values in, and then a certain value comes out. Okay, so we're plugging things in and getting something else out. And so our input, which is oftentimes X, but it can also be Y, is like the money. It's the number that you put in for X, and the output is like the candy. It's the value that you get out. Okay, so input and output table gives you an ordered pair that creates the graph of the equation. So remember, an ordered pair is what we graph, so the X and the Y. And it makes sense because these have to be in this specific order. So if I were to graph this point, I know that I'm going to run 3 because that's my X along the X-axis, and jump 4 because it's along my Y. So it's ordered, and they are a pair. And so I'm going to get a number of ordered pairs and graph those. We plot the ordered pair on the coordinate plane and connect the dots. And our line is also going to have arrows, if you notice, because this line will continue on and on forever. Linear equations should have graphs. All of these that we're using are linear equations. And if you look at the word linear, you see the word line. They're all straight lines. Nope, if your graph is not straight, then something's wrong. Maybe you've plotted wrong, or maybe you've weren't paying super close attention to your negatives and positives when plugging numbers in. So if we look at our input and output table here, and a lot of times your input and output table is just going to be as simple as this, X and Y. This extra column here is to show you what we're actually plotting. You won't generally have this, and you won't generally see this. It's just something extra I added for our notes today. So right here, all of these values represent X. So if I tell you that X equals -2, you're going to plug it in. If I tell you X is -1, you plug it in. If X is 0, you plug it in. So we're going to plug in 1, 2, 3, 4, 5 numbers for X here. And if you notice, our answer is going to be what Y equals. So I'm going to draw a little bit more work than sometimes you have to do. So I'm going to write Y equals -2 times X, but my X value in this case is -2. And so Y equals -2 times -2 is +4. If Y equals -4, I'm going to put it there. Okay, so I can write this out every single time. We are only doing one thing to every single X here. We're taking -2 times X, which happens to be -1 there. And negative times a negative is a positive, so we've got 2. Okay, you can also do this. I'm multiplying -2 to every single one of my X's. -2 to 1, -2, because all of these represent X. So -2, anything times 0 is 0. -2 times 1 is -2. And -2 times a +2 is -4. So now this extra, all this says is that we're going to plot -2, 4. We're going to plot -1, 2. We're going to plot 0, 0. We're going to plot 1, -2, and we're going to plot 2, -4. So we're going to run -2 and jump 4. We're going to run -1 and jump 2, and run 0, 0. And if I accidentally, let's say I run 1 and I jump 2 on accident, well, I know this isn't in a straight line, so I'm going to go ahead and check and make sure that I'm doing that right. Before I go back and check my work, all I have to do is check, oh, I'm supposed to be going in a negative direction. So just check your graphing first. Run 2, jump -4. And then you're going to take your card, your lanyard, to help you draw your line. And then they get arrows here. Because what you'll get to do in algebra next year is you get to choose any number you want. Generally, we pick the easiest numbers. These are generally the 5 numbers that you want to pick. But you could pick 10 or 100 if you wanted. This line is going to continue in a straight line forever and ever and ever as long as you want to go. So those arrows are going to help us represent that. So now here our equation gets just a little bit more complex, right? So we're not just multiplying or dividing the x, we're also subtracting a 2. So this reads y equals x divided by 4 minus 2. So every single one of these x, I'm going to divide by 4, and then I'm going to subtract 2. This isn't a lot of room to work, so I would probably do it right here. -8. I'm going to plug in all of these numbers for x. -8, -4, 0, 4, and 12. Divide by 4, and then subtract 2. Okay, and -8 divided by 4, you know we divide before we subtract, so -8 divided by 4 is a -2 minus 2. And right here, -2 minus 2, same sign sum, and they're both negatives. That means this has to be a negative answer, so -4. And then this next one, I'm going to plug in this one right here. So I've got -4 divided by 4 minus 2. -4 divided by 4 is -1 minus 2. Same sign sum, and my negative is bigger, so I've got -3. And then here I'm going to plug in 0 for my x. 0 divided by 4 minus 2. Anything divided by, 0 over 4 is 0 minus 2, and that's -2. And then I'll do this one over here. 4 divided by 4 minus 2. 4 divided by 4 is 1 minus 2. Got different signs, so I do have to subtract, and 2 minus 1 is 1, and my negative is bigger. And then I've got 12 divided by 4 minus 2. So 12 divided by 4 is 3, minus 2 is 1. So these are the points that I'm graphing. -8 and -4, -4, -3, 0, -2, 4, -1, and 12, 1. And over here, so I've got -8. This goes to 7. It doesn't go to 8. That's okay. We'll just be off the graph a little. And all the way down here to -4. And then I've got -4, -3, run 0, jump -2, run 4, jump -1. And I can't quite run, that's supposed to be a 12. Can't quite jump 12, but I'm going to be 1, and it's somewhere over there, which looks pretty good to a straight line. And draw my arrows. Okay. So same thing here. We're just plugging in -2, -1, 0, 1, and 2 for the x there. So we've got 2 times -2 minus 6, and solve that. 2 times 0 minus 6. I skipped one. I'm going to do this one over here so I have room to work here. 2 times -1 minus 6. And I'll do this one over here as well. 2 times 1 minus 6. And 2 times 2 minus 6. I'll do a few of these, but I'd like you to fill these in on your own. So pay attention to the negatives. 2 times -2 is -4 minus 6. Same sign sum, so we've got to add those, and my negative is bigger, so it is -10. I'll come over here and do this one. 2 times 1 is 2 minus 6. Different signs differ, and my negative is bigger, so that's a -4. So I'll let you finish those. Make sure your plots are in a straight line. I want to jump down here to D. So I'm plugging in. I'm going to start by writing 1 minus x. The only thing I'm plugging in for is x. And I don't want to plug in a 2. If I just wrote 2, I wouldn't be plugging in a -2. So I actually have to write that -2. And we know that two negatives, when you're adding and subtracting, make a positive. Because if you take away a negative, that's positive. Like imagine someone taking away your debt. That's a good thing. That's a positive thing. Okay, so we chop those. Even if you use parentheses, you chop those, and you get 3. Okay, so I might even do 1 minus this number, 1 minus this number, 1 minus that, 1 minus x, 1 minus this, 1 minus that, 1 minus that. So 1 minus 2, different signs differ, and my negative is bigger. That's -1. Okay, so I'll let you finish those. Okay, the difference here on E, if you notice, we aren't always given x. Sometimes we're given y. So here I'm going to plug this in for x because it's an x value. And I'm going to plug this in for x because it's an x value. But this isn't an x value, it's a y value. So I'm going to plug it in for y. So I'm writing the same thing, y equals negative 2x plus 1. However, I don't want to write y because I know what y is. I'm going to write negative 3. Okay. And if I want to solve for x, I need to get x alone, right? So we box our variable term, and that 1 gets away first. So negative 3 minus 1, don't just say 2, same sign sum, and my negative is bigger, so it's negative 4. Always be very, very, very careful with those negatives. Okay, and drop what I haven't done yet, divide by negative 2, divide by negative 2, and x equals a positive 2, because when multiplying and dividing, two negatives makes a positive. So when I plugged in 3 for y, x equals 2. And then you're going to do the same thing with 9. So instead of writing y, I'm going to write 9. Negative 9, negative 2x. Always make sure that you're, if this is negative, drop that negative. It's really easy to accidentally forget that or just not pay attention. And I've got a two-step. Box that variable term, subtract 1, they cancel. Again, pay attention, same sign, sum, and my negative is bigger. Divide by negative 2, divide by negative 2. And x here equals 5. Okay. And if you want, we can practice doing this. This stays the same, so we can write y equals negative 2 times negative 4 plus 1. When I multiply two negatives, I've got a positive plus 1. And when I plug this in here, negative 2 times 1 plus 1. So this is negative 2 plus 1. My negative is bigger and different signs differ. So then you should be able to plot that as well. All right, coming down to this word problem in F, I want you to do on your own. And G. So it says the function rule L equals 2W plus 6 relates to the weight L of a puppy after W weeks of being alive. Make the table to find the weights after 3, 7, and 10 weeks. So our table just needs to look like this. The problem is that we don't have X and Y. We have L and W. But if you recall, the rest of our notes are all Y equals, Y equals, Y equals. So it's set up Y equals. We're going to replace this. So instead of Y, they used L. And instead of X, they used W. So it's the same thing. This might make it a little clearer. Okay, and they'll always tell you W represents the weeks here. So this is our weeks. And right here it says L is the weight of the puppy. And so the L will be the weight. Right here, 3, 7, and 10, it says that this represents the weeks. So I'm going to put it under the column of weeks, W. 3, 7, and 10. And then I'm using this function, so Y equals, or I could write L for the weight equals 2 times, well, the first set of weeks I want to try is 3 plus 6. And then I can write L if I want. L equals 2 times 7, because that's my next input, plus 6. And L equals 2 times 10, that's my last input, plus 6. And then we're going to solve these. 6 plus 6, 12. Y equals 12. 14 plus 6, L equals 20. And you do that last one on your own.